This video is going to show you how to define a function in the Calculate sticky, and you can use that function then to calculate derivatives and integrals or just graph them. So we're going to show you both. So we're going to be looking at the Calculate sticky and the graphing sticky. So the first thing you want to do, we have a situation here where we're given a function and we're being asked to find its derivatives, so the first, second, third if it has one, and also its integrals, and graph them. So I just want to show you how that could be done without having to rewrite this every time. So we're going to pull up our Calculate sticky here, and the first thing we want to do is actually basically set this function or define it in the Calculate. So we're going to use f of x, and instead of equals we're going to use this colon equals, which is the define function. And now we're going to enter this function in, and I could type it in, but since I have it already done, I'm going to just copy, so Control C, and then go back to my function and Control V. And now when I hit enter or execute, it's going to set that function as being defined. So now anytime I use f of x, it's automatically this function that it's working in. So I could evaluate, f at 3, and it would evaluate based on this function. Since we're in the Calculate sticky, we could now just calculate the first, second, third derivatives if there are any, or the integrals by using the templates. And you can also use those same templates in the graph. So let's just show you at least one way to use the templates to calculate the equation for the first derivative. And you can then do the same process for the next. So the templates exist in the math. So when I'm in a Calculate sticky, I get a soft keyboard, and under the math, there's 2 tabs, and the templates that I need are in the second tab. And so you'll see here's my derivative. So this is a derivative just for the first derivative. This is if you have derivatives beyond the first, so second, third, fourth, whatever it might be. And then here's your integral. So we're going to click this template first, and we're defining for the x, and this function which we've already defined, I don't have to re-enter it. I can simply type in f of x. So I want you to see what happens. This f is bold, which indicates that this function's been defined already. You're just using it. And when I hit enter or execute, you will now see the equation for the first derivative. So that's really nice. We could do that for all of them. So if I went back and hit this one, now I have a second derivative. Notice that it has different templates thing here. So if I put in the x and then I put in that exponent for second, it automatically fills in that top one as well. And again, I'm going to use my define function, and it's going to find the second one. So as we would expect, if our function is a 4th degree polynomial, my first derivative is a 3rd degree, my second derivative is the 2nd degree, and my third derivative will be a linear, right? So we can just confirm that by actually doing this. So here is our, oops, I used the wrong one. So let's go back. I wanted to use this one. Oops, going real, okay, let's just delete. That'd be easiest. So now let's use this. We want to make sure we're using this one so that we can get that third in there. And now f of x again. And there's the equation. So in the Calculate, you actually see the equations, right? So you're seeing that connection. So if I just wanted to graph it and not see the actual functions and have the students figure out the functions, we could do that as well. So I'm going to move the calculations kind of out of the way. And let's say we went just right to graph instead. So now we're going to go into graph, pull out a graph, and we're going to get our equation sticky. And we're going to enter our original equation, which we've already defined as f of x. So we're just going to type that in here. So notice that the f is again bold because it's already defined. So when I hit enter or execute, it's going to graph that particular function that was already defined, which was a 4th degree polynomial. So it's kind of a funky looking graph. And now I could graph the first derivative. And again, using the templates exactly the same. I'm going to hit y equals, but this time I want the first derivative. So I'm going to go into math, my second tab, first derivatives right here, and use my f of x that I've defined already, and now it will graph that. And so you could stop here and sort of explore. You could maybe look at table of values and compare these two graphs, and what do you notice? What's the shape of this graph compared to the original? So the derivative looks like it's a cubic compared to the 4th degree polynomial. So you could start making connections that way by using the tables or the graphs. You could look at key points, those types of things, and help them try to figure out how to get to this first derivative from the original, and then verify it with the calculation. So lots of different ways that you could explore this going on. So let's move our table over here. Why isn't it letting me move the table? There we go. Actually, I'm going to get rid of the table. I don't need it right now. So you would do the same thing for the second derivative. And notice that each time you get a different color, and we're going to go into math again. And we want to use the template that is for a higher degree. So second derivative of f of x. And we can do the same thing for the third derivative. We're going to use that same template again, except this time we're going to choose a 3. And finally, and so we already kind of figured that out when we did these calculations, that the third derivative is a linear, and so you'll see that the yellow is a line. So all of this is confirming what we calculated. And finally, let's look at the integral, and let's change this to a different color as well. So the integral is also a template. And if I go to the second tab, you'll see here's the integral right there. And we're not going to put any values in. We're just going to put in our function. Oops, I'm putting it in the wrong place. Yeah, it's there we go, f. So again, anytime I use the f, it is going to be bold because it's already been defined. Oops. There we go. Did that wrong. And there's my integral, which is this one right here. So lots of interesting things that you can do very quickly with graphing, and then you can also go back to calculate and have them make some connections, look at the tables. You can also turn things on and off. So let's say I wanted to look at the original function and just its integral. I could either turn these 3 off. So when you click on the color, you can hide the graph until you want it again. So I could do that for these 3 so that I don't see them. And I only see the 2 I want. So here is the original function and its integral. What's the connections? We could look at the tables, those types of things. I could also, if you notice, each graph down here has its own tab. I could pull out any graph, and just by grabbing its tab and separating it out. So if I want to look at it that way, so I'm comparing these separately, and turn them back on, turn them back off. So lots of different ways to explore and look at the different graphs and kind of make those connections for students.